Hi everyone, this is Roy Chua of EbitThink. Thank you for joining us today on a ride through San Francisco with Galeal Zino, co-founder and CEO of Net Foundry. Net Foundry recently raised its first round of external venture funding. Let's get started with our conversation on Net Foundry's unique approach to cybersecurity offerings. Welcome, Galeal, to San Francisco, and in your first Waymo ride?
It is.
Excellent. Well, it's self-driving vehicle here in San Francisco, which is actually quite remarkable given how complicated the San Francisco streets are. Right?
Absolutely. The logistics are excellent, actually.
Yeah, it's actually remarkable. So let's get started. Why don't you introduce yourself a little bit and tell us about Net Foundry and a little story, and then we'll get going from there.
Yeah, Galeal Zino, founder and CEO of Net Foundry. Let's talk about Net Foundry in the context
of a self-driving vehicle.
Yeah, it's
exactly.
actually a pretty good conversation.
Yeah, let's do that. Yeah.
So we've actually done autonomous, we've done drones, we've done robots. And what I mean by that, I'll give you a specific example.
Yeah. What does Net Foundry do for those things?
First I'll paint the picture. Actually, I can do it in an SF context.
Yeah.
Imagine, for example, there's an earthquake or an earthquake warning. And you need to get emergency vehicles from point A to point B as fast as possible. And you want to make sure that passenger cars, et cetera, are not clogging the roads. You want to get them rerouted, this type of thing.
Yep.
And if they're mostly autonomous, then the question becomes, okay, how do we centrally control those vehicles and say, hey, make a right. Don't take that path because there's been an earthquake, an emergency, Godzilla came out of the ocean, whatever.
Yeah.
And of course that makes sense, and you need to do that. But the opposite is true, right? If you can centrally control and orchestrate these vehicles, whether it's vehicle-to-vehicle communication, V2X, whether it's centralized controllers, so then can an attacker.
Yeah.
And an autonomous car or a truck is essentially a missile. And so what we did with Lockheed Martin and the University of Auburn is we showed how you can do all that V2X communication over a native zero trust network, a Net Foundry network, so that you can control the vehicles in these type of emergency situations, but any type of attacker literally has no access into those vehicles.
Got it. Now that's really interesting. So if you were to describe Net Foundry and what it is that Net Foundry does to, say, an enterprise CXO, right, or to someone involved in IT or OT, what would you say Net Foundry is, and what does it do?
Yeah, I'll give you the simple at first. It's the only way that you can establish a private global network between anything and anything, between an autonomous car and a server, between a drone and someone with a 5G handset on the ground, between an API and the agentic AI that's talking to the API. So basically, the world's solutions today, even though we don't realize this because we talk a lot about zero trust and SASE, the reality is once you get out of the WAN, it's VPN or internet. And so all these agentic flows, all these autonomous flows, all these IoT flows, are not secure.
That's true.
Now in Net Foundry they are.
That's true. Yeah, I mean, vehicles like this one, for instance, there is no SASE gateway that's attached to the vehicle, generally speaking, and historically it's been either open communications, right, or you have to build your own secure encryption complicated stack, right, or you would have to use just a VPN, which is what people historically have done. How is this different from like a regular VPN that maybe some of the listeners are familiar with?
Yeah, actually, you hit the nail on the head. A lot of these cases, they'll use what's called a private APN, so it's a private mobile connection.
That's right, private APNs, that's correct.
But it's almost a dangerous illusion because really what a private APN does is it takes the traffic to the nearest cell location, like a PGW or whatever's there, and then it's a VPN from that PGW back to wherever the server is, let's say AWS, Azure, GCP, whatever. Right. The same VPNs that we've said, wait a minute, opening up a huge network level tunnel is a really, really bad idea.
Right. That's right.
Let's not do that inside our WAN with SASE, and yet we do it for more critical workloads outside the WAN.
I think that's fair, and that's fair. So I think the concept of zero trust, I think people understand. It's easy to say, hard to do, and what it sounds like is, with the Net Foundry technology, that it provides you with the ability to have a zero trust secure connection for critical things like vehicles, for instance. So beyond automotive, right? What other industries would be interested in the technology that Net Foundry has?
We have the most amount of adoption in the industries that care about security and need to do it at scale.
Got it.
So financial services, we're in a majority of the top U.S. banks, the top 10 U.S. banks. We're in 2 of the Fortune 5, so 2 of the largest 5 companies in the world. We're in healthcare, and we're in critical infrastructure. So we're in places like electrical grid. I mentioned kind of a MilGov deployment.
Yes.
These type of places where security is really important. And I'll add, and you kind of mentioned it, historically, the problem is you were forced to make this trade-off where if you wanted security, you also had complexity. And you had infrastructure, and you had IP addresses, and you had VPNs. And I know it sounds a little bit like marketing speak, but the reality is if you do secure by design, just like when we did DevOps and we shifted left over there, if you do secure by design, maybe you call it shift down into the network, all of a sudden it becomes a lot simpler to implement. So that's where we found the most amount of traction so far.
I think that makes sense. If you secure the underlying layer and provide an abstraction that's in fact secure, then the communication on top, you can not worry about all the complicated things about identity, authentication, mutual authentication, all those complicated things that you would otherwise have to build yourself, right? And maybe you get wrong.
That's
in this case, right?
And you're right. We provide identity, authentication, authorization, mutual. We provide all that as a service. But really critically, we reverse the model to say, if you start with an inherently insecure network, a normal TCP/IP, whose job it is to deliver packets, unauthenticated packets, authenticated packets, good packets, bad packets, TCP/IP doesn't care, doesn't know. And then historically, we've bolted on top of that a bunch of day 2 security to compensate for the fact that, oh my gosh, now there are some bad packets. It's not just a university lab talking to another university lab. Where we reverse the model. We said, actually, you know what? We're not going to rebuild TCP/IP overnight. We're not going to be able to get that into every router, every switch, et cetera, et cetera. But we can do a software-based overlay that takes the opposite model that says no packets are allowed on this overlay unless they have been strongly identified, authenticated, authorized. So that at that point you're defining what is permitted on the network. For example, this autonomous vehicle talking to some server that it should talk to. And anything else by default cannot even get on the network.
No, I think that's very secure, and obviously that's the model you want for critical infrastructure, like this vehicle, for instance, or any kind of industrial or critical infrastructure, like oil, gas, or potentially state and local government applications, or law enforcement, public safety type stuff. That makes a lot of sense. Given some of the verticals you talked about, manufacturing and obviously financial sector, are there any customer names you can share, or maybe rough descriptions of those customers that are actually using Net Foundry today?
Yeah, I mean, you mentioned manufacturing. It's highly interesting. Manufacturing is maybe 15% of the world's GDP. It's largely air-gapped, or at least not very connected. Tomorrow, with robotics, with edge AI, with preventative maintenance, with digital twins, with energy optimization, increasingly these manufacturing sites, and the same is true for electrical grid, by the way, distributed energy, et cetera, they do have to connect outside. And so, for example, we have one of the world's global industrial automation leaders headquartered in Germany, who has built us into their products to make them zero trust native, such that whether it's a manufacturer or a grid operator or whoever is using their vast array of products as an industrial automation leader, not only is it a zero trust connection, OT or IT did not have to go and figure out port forwarding, IP addresses, VLANs, VPNs.
That's always been a mess. No, I think that's the complicated thing, which is that you're trying to track all these complicated, just like traffic in San Francisco, you're trying to track all these complicated things, and then the reality is that if you secure and let an expert, so to speak, or expert stack take care of all the complicated things below, you can just focus on getting your applications right and not worry about the other elements of it. I think it's surprising how many people try to do their own thing and roll their own thing, and you think that I got historically it was sort of OpenVPN or FreeSWAN or whatever stack it was, and now let's do WireGuard, but they handle the encryption portion of it, but the whole infrastructure around the trust issue, the identity issue, the management, certificates and mutual authentication, all that's the messy part that people always get wrong. And that's usually where the weakness is not the actual transport encryption protocol, it's everything else, right?
I agree, and you see the quote unquote root cause of all these cyber attacks, and it's always like, oh, it would have been fine, except they didn't upgrade, or it was misconfigured, or there was a business logic. Well, of course, those things are going to happen
Right.
when it's such a complex day two operation.
Yeah.
So I completely agree with you. And even the encryption part, it did make sense for the world to trust Zscaler, Palo Alto, et cetera, with their encryption keys.
Yes.
Because those clouds have the access to their keys.
Fair enough,
And that was
yes.
probably better than where we were before.
Yeah.
But we've kind of taken that a step further, and just the way our solution works is the encryption keys stay sovereign to the endpoints.
Yeah.
So we don't have them. Zscaler has them. Nobody has them. They're literally on the endpoint. So it's just, for the type of use cases we do, that kind of data
That's
sovereignty
critical.
is
It
pretty
data
important.
sovereignty, the end-to-end elements of it, I think is important, especially as you said, you have clients all over the world, and especially those in the EU have a particular sensitivity, right, to someone else holding the keys, especially if that organization is not native to Europe, for instance.
Absolutely.
Right? Yeah.
Absolutely.
No, that makes a lot of sense. That's really cool. So, given you've got obviously good traction, I know you've dropped some names already of customers, pretty impressive.
Thank you.
And especially those you can't name, but we'll leave it at that. So what's next on NetFoundry?
Yeah, so we like to say we want to make the world a more secure place. And you're right, we started with some, quote unquote, very impressive names.
Very impressive names, yes.
And in a sense, we've kind of punched above our weight as a startup. But the reality is, the reason to use NetFoundry is the strongest in Fortune 500 banks, in critical infrastructure, in manufacturing. So it's not, it makes sense. Now, that should be the model everywhere, right? And so where we're starting to kind of spread in terms of laterally is just, because networking is obviously horizontal.
Yeah.
So yes, finance, healthcare, these ones are going to continue to lead the charge, but retail is going to go there too.
Yeah.
And so is hospitality, and we can name so that's one area of growth.
Yep.
And then the second area of growth is, generally speaking, networking, secure networking as part of a business transformation type initiative. So in the quote unquote old days, I know it wasn't that long ago.
Exactly.
It was building cloud native apps or lift and shift of apps to the cloud.
Right.
App modernization, digital transformation, these type of things. Now it's like AI, agentic AI, where people are kind of like, well, wait a minute. I want the AI or the LLM, I want it to be local, sovereign in my data center for great reasons, right? The data it's talking to is really sensitive data. But the irony of the whole situation is that data center has to talk to the rest of the world. And as we talked about earlier, what does it do? VPN, whitelisted IP addresses. So people are starting to say, okay, cool, why don't I just create a application-specific network, a network literally that agentic AI uses to talk to its databases, uses to talk to everything else it talks to, and nothing else is allowed on the network. So it's quarantined, isolated by design, instead of trying to have to figure that out after the fact. So that's another large growth area for us.
Excellent. Yeah, it's a nice day here in San Francisco, actually. It's
beautiful.
It's Transamerica right there.
I've been walking all week, and I love to walk. Even the hills of San Francisco, I love to walk.
It's nice. It's a nice walkable city for the most part. Yeah.
But this is a good excuse to see the sophistication of these.
It's remarkable.
Autonomous vehicles.
Yeah. It's actually remarkable considering the complications of San Francisco. It's really complicated. It's almost as complicated as building a zero trust network, isn't it?
Well, we can help make it. If you, as long as you do it by design, as long as you go secure by design, then not as complicated.
So if someone were to wanting to start using NetFoundry, right? There's sort of the different use cases, because one of the key things about NetFoundry that's a little different is that you taught yourself as sort of embeddable, right? And so a manufacturer, an OT manufacturer, can actually take that SDK and embed it into their systems, as opposed to you buy off the shelf, the ZTNA type solution.
Yeah.
So let's talk a little bit about that. How do I consume NetFoundry?
Yeah. So you start with this kind of zero trust native network, and we just spin that up for you, just like you would spin up VMs in the cloud.
Right.
And just like AWS is allocating you some compute blocks, and it's under the covers, and there's a lot of sophistication, but you're not dealing with it.
Yep.
We do the same thing. So we'll spin up a global network for you. And then the idea is, okay, what do you want to connect?
Right.
And so we try to be as flexible as possible with the endpoints, so that you could literally connect anything from an agentic AI to an autonomous vehicle to a drone. So there's three general form factors. You mentioned the SDK.
Yes.
The SDK says, hey, look, you don't want to put an agent on a device.
Yep.
Maybe you can't put an agent on a device.
Right.
Or maybe you can, but to manage that over time is operationally expensive. Take your application, compile the application with our SDKs.
Yep.
And what happens basically is when the application goes to talk to the network, to pass packets to the NIC or the virtual NIC, our SDK functions as like a layer 3.5 shim, call it. And it just wraps around that network interface.
Got it.
And it's oh cool. Okay, autonomous vehicle, you want to do this communication. Not so fast. Don't just delegate that to the network. Let me do identity, authentication, authorization, encryption. Let me do it all right here. So move the policy enforcement point, in this case, all the way into the memory space of the application.
Got it.
And that's where it's encrypted.
Got it.
And so then it's going to be a natively microsegmented session all the way to, let's just say, the server or whatever it happens to be talking to. So that's the SDK implementation.
Got it.
Sometimes you have the opposite situation. Maybe it's a legacy app. It's spaghetti code. You're going to modernize it next year.
Right.
But in the meantime, you need it to be secure.
Correct.
So in that case, you usually can take our software-based agents, where we took our SDKs, primarily our CSDK, and we built OS-specific agents for Windows, for Mac, for Linux, for iPhone, for Android.
Got it.
And you just grab them out of the store like you grab anything else.
Got it.
You then put that on the device. What is a little bit different about these agents compared to, let's say, VPN or the typical kind of ZTNA SASE tunnel that brings everything to a cloud?
Yes.
As you imagine, with our kind of SDKs, we have the ability to look at each application independently and decide what is best for that application according to the enterprise policy. So if the enterprise policy says, hey, like if Galeal's going to Netflix, then I want you, NetFoundry, to either send or let that data go to an internet gateway or a SWIG, or then we can do that. If Galeal's using a business application, then take that on the Zero Trust network.
Got it.
And where that one becomes really important, and then I'll come back and tell you my third endpoint type, is supply chain type stuff. So all these business to business transactions that today are almost impossible to do on a private network. Let's just take, for example, a hospital that's talking to a healthcare exchange. And of course, you're not going to take, hopefully, you're not just going to do like an IPsec connection from that hospital's firewall to that exchange and to hundreds of other hospitals, and then have that have a VPN connection back to, because now you're literally subject to a weakness anywhere there. So with our agent in that manifestation, which they usually just put on top of their firewall, they can put it in appliance, they can containerize it, they can virtualize it. What that agent's going to do in any of those form factors is to say, okay, cool. Healthcare exchange data, let's do this with it. Zero trust stuff. Something else, let's just say that there was a 0-day or malware or something else, and it wants to talk to the healthcare exchange. No, it's not going to let that happen, right? That's not an identified, authenticated, authorized session. So SDK, agent. Third one is more of a gateway model, and this is classically like in a DMZ, in an edge, and it's kind of like you have a bunch of devices, whether it's OT devices, IT devices, servers, they're back here, and you don't necessarily want to put agents on all of them, or at least you haven't done it yet. And so we're basically going to function as a zero trust gateway. We're going to turn that site dark to the outside world. So this is our dominant deployment for Azure, AWS, GCP, Oracle, where they're going to put us in their VPC.
And then everything goes through the VPC gateway.
And then it's outbound only from their private VPCs to the rest of the world to a private Net Foundry network. Which means they're inbound firewalls now deny all packets. So now they've made Azure dark or GCP dark or whatever without express route or direct connect or any of these type of things.
Got it. And that is similar to a lot of the ZTNA gateways that they put into enterprises without the other options that you provide, which is a lot more flexibility around those.
It is. The other key is what you really want to do is make your firewall rules be deny all inbound. And quite honestly, when we talk to people who are using ZTNA cloud or SASE cloud, I'm like, okay, cool. So your firewalls are deny all inbound, and they're like, no, because we have all these flows that, all these flows that they can't handle. It's server-initiated traffic, it's OTA updates, it's VoIP, it's video, it's FTP. It's these dynamic flows that, none of the big cloud providers can. So that's kind of our litmus test. Like, is your firewall really denying all the inbound traffic at the edge of Azure, AWS, or whatever? If not, we'll help you just do that, and we'll take care of those other flows for you.
And in essence, anything that calls in really needs to go through a gateway and be checked. But as you point out, for convenience and of expediency, or because they don't have enough edge endpoints in the classic ZTNAs, that they'll, let's just punch a hole through that because XYZ is too slow, XYZ doesn't work well, XYZ whatever, right? And that's And then you're like, okay, you secured everything and you left the door open. You're like, yeah, but the gate is open, but that's fine. No one's going to come through that.
The
right?
gate is open,
Yeah.
and then it gets left open. So our more sophisticated customers have done just-in-time access.
Yeah.
So it's like there's no access.
Yeah.
And then someone opens a ticket in ServiceNow or Jira or whatever. That's an API call to us that says, hey, cool, add an attribute that says until this ticket is closed or timer expires or there's a state change, allow 443 for this identity to this service. And then auto close it when you're done, right? So you get this just in time. Once you turn everything to software, you can do just in time.
Exactly. And that flexibility, that limited standing privilege, I think that's the model we're all trying to get to, right? But it sounds like NetFoundry makes it a little easier.
Well, it's just too hard to do with IP addresses. When you're using an IP address as your proxy for an identity, it's impossible, literally.
Yeah, no, it is. It is. And that's the unfortunate thing, which is that even walking, show floors at conferences like RSA, for instance, or talking to vendors, and briefings and all that, there's still a lot of IP addresses out there. I mean, that's unfortunate, right? And you're right. IPs are a very poor proxy for identity, but that's been the way for 3 decades or more, right?
Well, that's an interesting thing, right? The internet TCP/IP architecture was absolutely brilliant, especially for what it was designed for, which is connecting these university labs and government organizations. But in the meantime, the world's changed just a little bit in 3 decades, right? And so digital transformation has left networking in the dust. Why? Because you can't go back and change the fundamental TCP/IP stack, Cisco routers, Juniper routers. But what you can do is put a software overlay on that to make an actual, what we call Zero Trust native network on top of that TCP/IP stack.
Yeah, no, that makes a lot of sense. So congrats on the recent round of financing.
Oh, thanks.
Congrats again.
Overjoyed to Sin Ventures anchored the round. Sin, in my opinion, is the best cybersecurity VC on the planet. And so we're excited to be partnering with them and helping to bring NetFoundry to the rest of the world.
Yeah, that should fund your enterprise global expansion, right? It's like
There is as a horizontal kind of solution, just like cloud. If you look at all the use cases in cloud, it's considerable, right? It's still just compute, quote unquote, right? And for us, it's still just a Zero Trust native network. But we have finance, we have healthcare, we have manufacturing, and they're different. And with our mission to make what we say effortlessly extraordinary networking, effortlessly extraordinary networking means it better be simple. So forget about security, performance, resiliency, reliability. Of course, all that's table stakes.
Right.
But if it's not simple, it doesn't get adopted.
That's the key.
And simple is different for a healthcare organization with the integrations they need compared to a finance integration, compared to manufacturing. So we have some work to do, and overjoyed to have
you have money to do it.
To do it.
Money to do it, and what I do say is actually simple takes effort, and simple takes energy and money, actually, right? So surprisingly,
it does.
It
does, and it takes the right partners. I think I've talked to I don't know how many other startup CEOs, startup founders, even more than all the Waymos we see out here. They're all over the place, by the way, which is kind of cool.
I know, it's amazing, the number of Waymos in San Francisco.
And you talk to a lot of them, and if you ask them, what was the biggest mistake you made, or if you could redo it, what would you do? And it's almost invariably one or two things. I picked the right investors, I had the right people in the trenches with me, and I'm very, very happy. Or the opposite. And the opposite is really hard to unwind. And so really happy to be partnering.
No, I think you have a good partner there, and your investor, and congratulations again.
Thank
and
you.
I'm sure I'm looking forward to seeing a lot more from NetFoundry.
Yeah, same. We want to multiply just like the Waymos.
Just like the Waymos, everywhere. Exactly. Your self-driving Zero Trust network.
Autonomous networks.
Autonomous networks. Exactly. Very good. Excellent. Well, always a pleasure, Galeal.
Yeah.
Thank you.
Yeah. Thank you.
Thank you. Right.
We made it.